right, so now we are on the second try it problem. Which of the following function equations is linear? Remember that if it's linear, it has to be x to the first power, all right? For this first one, we have y equals 2x squared, all right? So that is a curve, no. That's not the answer. Y equals 3 to the x power, all right? If that's the situation, then we also know from above here, all right, it says that that's nonlinear. It's going to be a weird curve. And then we have y equals x to the third power plus 5. And that also is not a linear function because it's also curving. We have y equals 6x plus 4. All right, and we know this is linear because this x is to the first power, right? It's not going to any other power, or it's not a power, so we know that this has to be the answer. All right, and then the last part about this. When you're looking at linear functions, all right, or it might not just be linear functions, it might be a nonlinear function. You can tell if it's increasing or decreasing, all right? So how do we tell that? Well, a graph is increasing when it goes up and to the right. For example, this blue line, all right, it started at 0, 1, and then it goes up and to the right, all right? It's going up, you can tell. A graph is decreasing when it goes down and to the right, and then that's this green one right here. It started at 0, 3, and then it goes, down to the right. It's decreasing. It's always going to be decreasing. Also, increasing functions, they have a positive slope where m is always positive. In other words, when you're looking at this equation, the x, all right, is always positive. There should never be a negative number attached to it. Decreasing functions will have a negative slope where m is always negative, all right, which is this example right here. When you're looking at this, you can tell that this is always going to be decreasing because we have a negative number that's attached to the x, all right? This slope, in other words, the slope here is negative. And if it's a negative slope, it's going to be decreasing. Now, you might have something that's interesting like this, all right? A graph can have parts that are increasing and then other parts that are decreasing. A graph can be constant as well, which means it's not decreasing or increasing at all. So here's an example. All right, this curve or this function, I should say, on this graph, it starts at -2, 0, and then it curves, right? It curves up, so it's increasing up until it hits 1, 3. After that, it's constant. All right, and it's constant because it's a straight line. So remember, constant is a straight line, but it's not going up. All right, this line has to be horizontal. After that, you can tell that it's decreasing, all right, right here, because it's going down. And we would say that it's decreasing from 3 to 4, all right, when x is between when x is 3 to 4. And how do you write that? Well, the right way to write this would be in this format. All right, so we would say x is increasing in between -2 and 1. X is constant in between 1 and 3. And then x is decreasing between 3 and 4. So now we're going to have some try it problems. Which of the following linear functions is always increasing? Well, if we go back to our notes, we can tell that it's always increasing when m is always positive, all right? So I just look at these examples, all right? Which one has a positive slope that's attached to x? Well, it's this one, right? This is the only one that's positive, positive 3x minus 1. For number 4, where is the function graph increasing? Well, you look at this graph, it starts here, it goes down, so it's decreasing. Oh, wait, but look what happens. Then it goes up, and then it goes down again. So it's increasing between 2